cutting short your break. You know, so please feel free to go visit the place and then grab something to eat. And thank you very much for introducing me a little longer, but okay. So my today's topic is waste prevention. I think I can change the slides. Yes. Okay. So uh, on this slide, you can also see there is a website www.greenchemistry-toolkit.org. So you can also download some valuable information about green chemistry, its principles, what exactly it is, different methods using this website. I would be covering a couple of slides. Don't think so many slides for each bullet point. We have 5 bullet points: waste treatment pyramid, reduce solvent use, waste as feedstock. Ibu Gelang already talked about feedstock utilization for energy, biodegradation of waste, and designing processes to include biodegradation of waste. I hope everybody must have seen this typical 4 hours. 4 hours: reduce, reuse, recycle, and recover. So prevention is better than cure, old proverb. So better we do not create monsters, so that we don't need to have some kind of treatment for the monsters. So best approach is prevention. So we will first start, let's say, most favored option is obviously prevention or reduction, reuse, recycling, and then when something is inevitable, we have to dispose it off. And we also need to see what we can get out of it in the whole life cycle of an element or a product. So various technologies are required for this. Recycling often requires composting for this municipal solid waste, and incineration is generally for energy recovery, and disposal finally goes to landfill. But in landfill also we don't just leave things, we try to recover whatever best we can. So coming to landfills, as you may be aware, the consolidated, all the material is buried into the landfill, but it actually reactions takes place, and then we can get biogas or landfill gas, because the same semi-anaerobic conditions are very convenient for the bacteria to eat up the biodegradable matter and create this carbon dioxide and methane. So if captured, landfill gas methane from decomposing garbage can be used to produce electricity, heat, and fuel. So landfills are designed in a way so that we can extract the gases. Then it comes to incineration. So right now I'm talking about the bottom of the pyramid, which you have seen. What kind of options do we have once we already generated the waste? And then we will slowly move to the top. Incineration is solid organic waste is combusted. Some thermal treatment allows energy capture, and solid mass is reduced by 95 to 96%. Here also, there are many kinds of incineration systems available. Very popular technology is mass burn technology, where it's a big monster or guzzler, which you feed whatever you want to do and it will burn it. But that's not the ideal situation. We also need to see what valuables we can recover. So mass burn technology are okay in some cases, depending on case to case, but it is always advisable to remove the valuables, waste segregation prior to this mass burn technologies. Pyrolysis is another thing where thermal decomposition takes place at a lower temperature in an absence of oxygen, and gasification, gases are generated. So this application, pyrolysis and gasification, is also very popular for biomass gasification and pyrolysis. So you can get a lot of valuable products, which includes biochar, bio-oil, gases such as methane, hydrogen, carbon monoxide, and carbon dioxide. In Indonesia, I did not see much, but in Southeast Asia, you can find a lot of gasifiers. Next to the rice mills, because rice mills, like in Indonesia, also we use traditional conventional rice milling, not the parboiled rice milling. It requires electricity, and then rice husk is gasified to generate that electricity, and rice mills are operating in an off-grid environment. Sometimes this kind of system can also be attached to the engine, and then you can get mechanical power to generate the rice mills. So gasification, pyrolysis is another important aspect which needs to be taken care of. Indonesia is blessed with a lot of biomass, but we hardly see any systems using biomass to generate power or gases, either by Rankine cycle or pyrolysis or gasification. Now, recycling and composting. Recycling is converting waste material into a new material or objects available for metal, plastic, paper, and glass. Generally, this kind of segregation should be done before the mass burn technology, where everything is incinerated into an incinerator. Composting is organics undergo a biological decomposition to form material, which is compost, and that will be useful at many places for the horticulture and farmers. Anaerobic conditions and biogas production. Ibu Gelang already mentioned this briefly, but this is creating in an maybe in a farmer's land, or it can be actually developed or built for a municipal scale. We have many examples where municipal scale biogas plants for after wastewater treatment are there, but they are also very popular in small units. And climate-wise, Indonesia has a good potential for this anaerobic digestion. It is a little complicated if you are in a too cold climate or too hot climate, but the moderate climate, which is in the majority of the places in Indonesia, is good for the bacteria. And this biogas can actually generate electricity, heating and transportation fuel. Many of the industries for their kitchen waste are not in Indonesia, but at various places use biogas generation if the food is cooked in their kitchen. But here in Indonesia, most of the industries are buying the food from the outside, which is a little challenge. But whereas wherever this food is cooked in a place, this kind of options can be actually implemented. And these are materials, and materials also are associated with the energy saving. So if you want to generate, or let's say manufacture the glass or paper or plastic or steel, if you are recycling it you end up using less energy than if you are mining the raw material as an ore and then processing it. So recycling of material is not only beneficial for the resource conservation, but also beneficial for the energy efficiency. Gasification is similar to pyrolysis, but temperatures are a little higher. It is almost at 700 degree centigrade. There are different kind of gasifiers available for different type of applications. For small applications, atmospheric gasifiers are available, so pressure is not very high. But for industrial or big applications, even pressurized gasifiers are available. Many of the applications involve gasification of the biomass. In fact, many countries have also tried gasification of coal to convert it into the liquid fuels, which is called clean coal to liquid technologies. So those are also large scale gasifiers which are applied for doing so. And in alcohol production, biomass conversion into a mixed alcohol fuels. So biological or chemical methods for converting any biodegradable matter in alcohols. It is basically enzymatic breakdown of biomass into simple sugar, followed by the yeast fermentation into alcohol. Now, when we talk about green chemistry, there are certain things which we can think of: reduce solvent or solventless processes, because solvents often are a little complicated in the chemistry, considering their chemistry. Cell preparation, process intensification, material deposition, and use waste as feedstock. So there are, I'm sorry for a lot of text, but yeah. So there are building blocks of both DNA and RNA. So which are chains of this blah blah blah. You can get the details in it. However, what I want to emphasize is a one pot, three-step sequence is generally involved and eliminates the need of several hazardous reagents such as zinc chloride and so on. So solvent consumption can be reduced to by 95%, and which can also lead to reduction in the hazardous waste. So this is specifically valid for uh, nucleoside triphosphate, which also serves the source of the energy. So this is one of the ways for reduction of solvents. Ethylene oxide is often used as an intermediate uh, chemical or compound for the production processes. So several, the most notable of which is ethylene glycol. It is also used as fumigant in certain agriculture applications, and also sterliant for the medical equipments and all that. So use of molecular oxygen removed the need of chlorine, and now new processes generated more than 16 times less waste than the original one, eliminating the formation of wastewater. Now, this is more of chemistry where solvents are reduced, and we can also have option where we can move towards solventless processes where solvents are actually not required. So chemistry physically activated through motion, friction, heat, and reaction. So you might have some applications where use of solvents can be actually removed, and then mechanical processes can be utilized for doing the process. For example, using a high energy ball milling, it is vibrating ball mill crushes the particles, which results in larger surface areas. Like if you go for cement production, you can find those examples. So mixing of solids allow reaction at surfaces. Thermal equilibrium is broken. So basically, what we are trying to do is from motion, friction, heat, and reaction, we are trying to avoid the use of solvents. So first step is reduction of solvents. Second is if we can get away from the solvents. Now, utilizing waste as a feedstock, some of the examples are waste cooking oil for biodiesel. There are various small insects. The shell, which is also available in Indonesia, this crustacean shell waste can be also utilized for different products. Red mud for bricks, and glycerol for lactic acid using catalyst. So these are few examples. If we go into this, then we have in 2011, US biodiesel production reached about 967 million gallons. One Olympic-sized swimming pool will be about 660,000 gallons. So you can imagine the quantum. And then current treatment, dispose or combust as fuel. So basically, catalytic oxidation of glycerol to chemical feedstocks. So triglycerides can be converted into glycerol and long chain fatty acids. So this will be the glycerol, and long chain fatty acids can be biodiesel. Now, glycerol, if generated, can be utilized to manufacture different kind of chemicals. So you can see skin exfoliating reagents, industrial chemicals, anti-freezing glycols. Uh, Glycols are used also into low temperature refrigeration um, systems to lower down the freezing temperature of the water. Then valuable medicinal products, sunless tanning products, and polylactic acid. So glycerol has a lot of potential for manufacturing uh, different products. So if we have this, the triglycerides can be converted into glycerols and biodiesel. So both products are good for. They have a good economic value. Now, production and application of lactic acids. Lactic acid also, there are various applications. It is used for food preservatives, edible pH modifiers in textile industries and cosmetic industries. Also, lactic acid is very popular ingredient for various products. So, 90% of the lactic acid comes from the anaerobic fermentation of hexose sugar, which is commonly known as cornstarch. So, compete with food sources and slow and requires a lot of purification. So this is the application for lactic acid. Then water electrolysis with earth abundant metal catalysts. So I think we are very much aware about electrolysis process where cathode and anode are used for oxygen and for generating oxygen and hydrogen. I just show this slide so that we can go to this next slide. So electrolytic oxidation of glycerol is also one of the applications where glycerol can also actually generate some side products, or glycerol or side products can actually result into finally the hydrogen. So this kind of application is also possible. The Bayer process, the red mud, which is very popular. Red mud is um, coming out of the production process of aluminum. So when bauxite as an ore is processed, so bauxite is the ore for aluminum, and it results into aluminum oxide and alumina. So for every ton of alumina produced, the process can have about one third of the ton of uh, 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 a third of ton to more than 2 tons of red mud. And this red mud is problematic because red mud is very toxic. So mud is also having high pH. So disposal of red mud is not so easy. It is often captured into big areas where evaporation takes place and red mud is then finally disposed of. Now, so this is red mud is generally kept in reservoirs. You can see few of the pictures how red mud is being utilized or kept. But also red mud is also having some applications. We can also utilize red mud because of its higher pH concentration. So if it is neutralized, it can be used for the building materials, cement bricks, tiles, etc., and also for the pollution control, removal of toxic heavy metals. So red mud has the property to remove these heavy metals, and removal of aromatic pollutants like dyes, phenols, chlorophenols, boron agents. So, but it is not very economically feasible. So this process can actually handle the red mud very well. So this is a neutralization of red mud through the selective extraction of sodium ions. So there is a metal and then a simple cathode and anode, and red mud is heterogeneous basic aqueous solution is put into a place where, and then we use a selective membrane which will only allow sodium to pass through. And then sodium hydroxide production can actually, uh, sodium hydroxide can be manufactured using this red mud. And red mud is can be neutralized at the room temperature. And so these are uh, some information about neutralization of red mud. So generally the pH is in the order of 13 for this red mud. Now, biodegradable waste, there are different definitions for biodegradability. So, limited biodegradability, completely biodegradable or substances. So, anaerobic processes versus aerobic versus anaerobic. Aerobic, as the name suggests, in the presence of oxygen, anaerobic in the absence of oxygen. Aerobic processes are generally utilized for the wastewater treatment, conventional wastewater treatment. You can find the aeration tanks there. And the byproducts are heat, carbon dioxide, and water. But you need to supply a lot of energy to do so, because you need to supply the air through a diffuse aeration system or surface aeration system to decompose the chemical oxygen demand, or BOD, biochemical oxygen demand. Anaerobic processes are less energy consuming, where it happens in the absence of oxygen, and then bacteria consume the organic matter. They eat the organic matter, and then biogas is generated. So because it is in the absence of oxygen, so methane actually comes out, and it forms a biogas, and biogas is considered as a renewable energy. So those kind of options can also be tried. Digestion versus chemical structure. So not all the chemicals are digestible. So it depends on the chemical or molecule itself, plus the process or bacteria which we are going to use for it. So some parts of the molecules are known to be more biodegradable, and some are not so much biodegradable. So there is publicly available software that analyzes the chemical structure and predicts whether the molecules will degrade at a slower rate or a faster rate. Design for biodegradation. So now we are coming, how do we not have these kind of things? So design for the product or the processes in a way so that we need not to have these kind of complicated process in the downstream. For example, for the plasticizers, we have options. So plasticizers are the additives for the plastic products, mainly used in PVC to improve the qualities of the PVC. Almost 90% of plasticizers are used in PVC. So dipropenyl glycol benzoate decomposes into the products which is toxic to bacteria, and therefore stops the biodegradation process. With a slightly changed structure, 1,5-pentaneodyl dibenzoate biodegrades into carbon dioxide and water. So it is worthwhile to look for options whether we actually want to use some raw material. So if we do not use the previous one, this one at the top, and we use the second one, then we are better off in the downstream. So here comes your product design and your approach how to handle things. And gradually in the Green Cam project also, we are trying to have pilots to look for alternative to POPs. So there are various pollutants, or let's say persistent organic pollutants, which are into the manufacturing stream. So if we can replace them. So this example is something like to just think about what can replace what. So alternative to POPs can also be thought of. Pesticides. So we have different type of pesticide. DDT, I think everybody knows DDT. Widely used, not so good. Then we have DDE, we have methoxychlor, and then methoxychlorphenol. So if we wisely choose these pesticides, so DDT is widely used, not wisely used, and it is very persistent to the environment. So this is also one of the persistent organic pollutants, which is pesticides. It goes to the biochain, this biocycle, and it is complicated. So not only does it bioaccumulate, but it also undergoes a reaction to DDE, which is even more toxic than DDT. Another option, which is methoxychlor, shares many insecticidal properties such as DDT, and its potency, but it is not persistent. So it will not go into the biocycle. So it is better, and if degrades into methichlorphenol, which has also low toxicity, and it is easily extracted. So options are many to use which kind of chemicals we intend to use. Detergents are another examples where tetrapropylene alkyl benzene sulfonate TPPS was used as a surfactant in the laundry detergents and accumulated into a water supply due to incomplete degradation. So water tend to foam when coming out of the tap because it is not utilized fully. So TPPS can be was replaced with LAS. So it reduces the carbon chain. This linear carbon chain reduces the biopersistence. And then antibacterial products, we can say low biodegradation and high biodegradation. So we should aim to choose chemicals which are highly biodegradable and not persistent. I think this is all from my side. So one takeaway which I can say, first try to see what can be prevented. If we do not use something and still we are okay, and then if we intend to use, then which chemical should be used. More thinking should be given not only at the manufacturing stage but also to its environmental on the adverse impact of the environment which it can have when disposed of, and especially if it is persistent, then it is more complicated. So it is not local, it will keep traveling from one place to another using our biocycle. Thank you very much.
Thank you very much, Mr. Salil Dutt. Please have a seat next to me with the microphone. So I would like to have a little summarize about your presentation, dan saya akan membawakan summary ini dalam bahasa Indonesia. Jadi tadi memang dalam konteks waste treatment itu ada tingkatan-tingkatannya, mulai dari disposal, energy recovery, recycling, reuse, sampai reduction dan juga prevention. Memang di pyramid itu prioritasnya adalah kalau bisa kita mencegah waste itu akan jauh lebih baik. Tapi kalau misalnya memang sudah ada ya produksi waste tersebut, maka banyak hal yang bisa dilakukan. Seperti misalnya dengan menggunakan landfill, incineration dan pyrolysis, kemudian recycling, reuse and repurpose dan lain sebagainya. Nah, tentu saja ini juga dilakukan dengan perhitungan yang matang agar saat waste itu diolah gitu ya, benar-benar bisa tidak memberikan dampak yang buruk terhadap lingkungan. Nah, dan dalam hal ini juga kita juga bisa memanfaatkan waste itu sebagai potensi feedstock. Di antaranya adalah terkait dengan cooking oil, jadi minyak jelantah ya mungkin dalam bahasa Indonesia, itu bisa diberikan treatment untuk bisa dimanfaatkan menjadi biodiesel. Kemudian juga crustacean shell atau cangkang dari makhluk-makhluk laut ya yang kemudian bisa digunakan atau dimanfaatkan kembali. Kemudian juga ada red mud untuk produksi batu bata dan lain-lain. Nah, dan hal ini juga bisa berpotensi untuk mengurangi kandungan-kandungan yang maksud saya untuk tetap bisa memanfaatkan kembali kandungan-kandungan yang masih bisa bermanfaat sehingga waste yang dihasilkan itu benar-benar limbah yang sudah tidak bisa terpakai. Baik, mungkin itu yang bisa saya summary-kan dari presentasi Mr. Dutt. So I will open the floor for the Q&A session. If you have any question, please raise your hand. I will give the opportunities to two people, maybe. One. Ya. Ada lagi? Okay, two. Okay. All right, sir. Please mention your name and also your institution first.
Thank you. Good afternoon, sir. Thank you for the opportunity for me. It's very interesting to hear from your end about the experience according to the red mud disposal, because previously we treated the process, but in the upstream. It means for the flocculant itself, for buyer process. And it quite limited technology provider to provide the flocculant that very effective and also give the quality to the overflow of the thickener itself. So I mean that the technology provider is very limited in this global players in the world. According to the red mud itself, I hear that this is a very toxic character. And on another side, we have to implement that it can be used to brick building. So how to convert from the toxic characteristic to be human being properties for the brick building. And then also in Indonesia, we have quite huge industry for the bauxite, from the bauxite refinery up to the chemical grade alumina and also smelting grade alumina in Indonesia. So I think if we can convert this easily or applicably in Indonesia, I think it is quite big opportunity for us. How to implement this regarding that gap between toxicity, and applicability, and also how to convert become industrialized base. So I think this is the idea of my question. Thank you. Good afternoon.
Okay, thank you very much, sir. Excuse me, what's your name, please?
Ryan.
Ryan, from?
Thermex.
Okay, thank you, Mr. Ryan. Mr. Salil, you can answer the question directly. Yeah.
Okay, thank you very much. First of all, utilization of red mud, whether is first you are going to neutralize it, make it non-hazardous, and then using into the brick, also need to follow law of the land. Okay, so as I understand, many of the hazardous waste or toxic waste in Indonesia are categorized as hazardous because of their source, and there is a limited potential. You need to work with the regulators or authorities if you want to prove that this waste is no more hazardous and treatable. So not only with the red mud in Indonesia, there are various other areas where sludge coming out from the wastewater treatment plant is also considered as hazardous, irrespective of the actual content of toxic substances into it. So that is first option. So first of all, need to see whether the Indonesian regulation allows it. Okay. Then coming to the technologies, there are various technologies because in outside Indonesia, in different countries, waste characterization is based on source and also on the characteristics. So if you go to Europe, or I don't want to always refer to Europe, even Southeast Asian countries or South Asian countries, waste characteristic is based on the concentration of the pollutants and also based on the source. So if that opportunity is there, there are technologies which can make it less toxic or non-hazardous. and it can be utilized then for the brick manufacturing or many other applications. So I think in Indonesia, we also have this regulatory challenge in addition to this technology specific challenges. I'm not sure if Ibu from MOEF or if somebody from MOEF would like to address this.
Okay, yeah. Hopefully it answered your question, yeah, Mr. Ryan. So the next person, yeah.
Hello. Yeah. Good. My name is Diana from PT Sigma Utama. I would ask some question that from your slide presentation, there's a heat mill, basket mill. Uh, uh, for industry of manufacturing paint, we use this basket mill or dino mill. So maybe you will ask, you will mungkin bisa diberitahu ke kami bahwa perbedaan antara menggunakan heat mill sama basket mill yang standar. Soalnya kalau cost and benefit-nya kan lebih berat, lalu berapa kapasitas dari heat mill tersebut. Kalau misalkan menggunakan heat mill, produksinya harus berapa banyak gitu.
Okay, maybe can you tell us about how different the use of heat mill and also basket mill? How is the capacity and to what extent it can produce the products at the end between the heat mill and also the basket mill? That's your question, right?
Okay, very specific to the paint. I'm not the process expert for the paint. This needs to be selected based on the demand or requirement. So if you need to select whether different type of mill depending on your raw material going in and what exactly you want mill to transform that raw material into something else. So maybe I'm not the right person to answer. I would like to give the floor to anybody in the house if you have some response to this question.
Ya, mungkin Ibu Diana kita bisa keep dulu.
If you can send me on my email some specific query, I can check and respond to you.
Yeah.
Thank you.
We will keep your question first. Maybe after this, the committee will also try to discuss with each other. So maybe in the next day, we can give the answer to you and found the right expert to answer your questions. Oke, baik. Tadi saya lihat ada penanya terakhir ya. Oh, mohon maaf Bapak, tadi ada Pak Yusuf tadi yang bertanya. Jadi Pak Yusuf dulu mungkin terakhir ya, Bapak ya. Oke, Pak Yusuf terlebih dahulu. Nanti panitia mohon bantu untuk ada satu penanya lagi nih di sebelah Ibu Mita. Ya, silakan Pak Yusuf.
Okay, good afternoon, Aja. My name is MY. You can call me MY from BRIN. It's like a research and research and innovation agency from Indonesia. So my question is basically like we did have a tin company in PT Timah in Babel. And that PT Timah has a problem with the recovery of landfill because of their activity before. Now they have the regulation. They receive the regulation that they should clean the landfill within some short period time. That is quite possible for them to clean this landfill. So my question is, do you have any like success story from other countries that has some under pressures from the regulations to clean with some contaminated landfill, something like that? Because this is quite challenging for us because PT Timah asked the BRIN to help to expedite this process. Thanks so much.
Okay, thank you.
Okay, this is, correct me if I'm wrong, this is referring to a landfill who has created some kind of contamination around it?
Yes.
Okay. So there can be generally there are two kinds of contamination which might happen around the landfill. One is soil contamination, and second is if it is used for a longer time, there can be a groundwater contamination also, right? So depending on, so there are various companies and various technologies who do this remediation of contaminated uh, soil and also the water. There are many cases globally where groundwater is also remediated or decontaminated using different bore wells, and then you suck the water from a bore well, it goes to a water treatment system, then it is put back to the ground. In case of soil, generally you need to uh, excavate the soil which is contaminated, and then it goes to the treatment process, the whole bulk soil. Even different industries, not only landfill, there are various cases where uh, structures in the industries are also impacted due to different type of pH of the chemicals like sulfuric acid, hydrochloric acid, which leaches out to the soil and water. So many technologies, many companies are already operating into this. Majority of them are in US.
Okay. Can I add more specific questions there? Because we have like a 3 years to complete cleaning this process. With what you said, how long it will take?
It depends on how much is the volume
The following
and
is Masa Island.
how deep the contamination is. Whether the contamination is still on a surface level where only soil is contaminated, or it has leached to the deep soil and groundwater. So first of all, you might have to do the study of the contamination, and then after that study, some scheme uh, can be there for decontamination of the land. There are many companies who do this. Many of the companies buy this contaminated properties at a throwaway price, right? And then they decontaminated the land, and they sell the land also at a very high price with high rise buildings, right? So different models are there.
Right. Thank you, Mr. Dutt. So the last one, yeah, please help to deliver the microphone to Bapak yang pakai baju hijau. Yes.
Okay, very good afternoon, Mr. Salil Dutt. Nice to meet you again. Yeah. Okay, my name is Hubert Widyastono. I'm from Indonesia Chemical Industry Federation, FICI. My question is related to your two presentations, which are quite interesting for me. You highlighted about the glycerol to chemicals, to other chemicals. And then the second one is about the waste and biodiesel. And Indonesia is the biggest biodiesel producer in the world now, at the moment. And currently, we are not just studying, but we are now conducting a very serious assessment to build a BioPG plant in Indonesia. And we have done our pre-marketing, and maybe we will import first the BioPG from Europe. My question is, since we process the waste or byproduct of biodiesel, which actually is a crude glycerin, and we go to market and we start developing our channel of distribution, there's one very critical question from our potential customers about the traceability.
About the
Traceability.
traceability.
Yes. So my question is, how we can solve these traceability issues when we want to develop these derivatives coming from this specific commodities, which is palm oil. Thank you.
Thank you very much. You can answer.
Yeah, I mean, if the source, the traceability has to be there. Now everybody is asking for it. If it is coming from source, it has to be like there are EU regulations now coming up with this traceability. So I think the question is two ways. One is technically how you establish the traceability, or politically, what are the political dimension of that traceability? Okay, so I would rather stick to the technical one. Okay, so if you have some product, you can always have some kind of signature from where it is coming in. And I mean, yeah, traceability, there are many systems available right now, many softwares. Um, by that, you can establish traceability, not a big deal, actually.
Yeah, actually, my concern is about because this is actually when we talk about the 12 principles of green chemistry.
Yeah.
At least 7, even 8. Yeah, we can comply because one of the things is that we process the waste. Yeah, the waste, and here Indonesia is ample. Again, when we start talking with our channel distribution partners, yeah, because they want to export this green product to Europe, to North America, and this is the very how to say is a critical issues, yeah, because we want to promote green chemistry, green product, green industry through our green marketing approach. But again, this is unanswered questions because the current situation that most people still outside there classify the palm oil as issue is related to the traceability. That's my concern, actually, Mr. Saki.
Yeah, so that's what I technically it's feasible, but how different products are perceived in different geographies once they are traced to some raw material needs to be seen differently.
Yeah. Hopefully it answers your question.
No, I'm sure I could not answer this question.
Well, actually, if you
But we can discuss. But we can discuss. No worries, right?
if you have do you want to have more discussion, we will have networking dinner session, so please stay in this hotel because at 7 we will have the networking session, so you can discuss anything that you want. Okay, so thank you very much, Mr. Salil Dutt. Please give big applause to Mr. Salil Dutt.